1.4 says determine the LCM of the following numbers by using prime factors. Now again, this question posed somewhat differently to others that you've seen, but it means the same thing. They want you to determine the LCM of those two numbers by using prime factors. In other words, you must use the ladder method, because how do you obtain prime factors for such large numbers? You use the ladder method or the factor tree method, which is something we didn't really focus on because, like I said earlier, our preferred method here is the ladder method. So 1.4, we will then do the same thing we did with the previous two numbers, only this time we are going to look for the LCM and not the HCF. So I'm going to take 1296 and I'm going to pop that onto a ladder. And I'm going to start dividing my smallest prime numbers into that. So of course, the smallest prime number that can go into this is 2. So 1296 divided by 2 equals 648. So that's 648. And again, there it would be 2. So divide by 2 and I get 324. Divide by 2. So that's 2 and that would be 162. And again it would be 2, get 81, and here it would be 3. Let's see that, to give me 27, and again it would be 3, and that would give me 9, and again it would be 3, and that would give me 3, and then 3, and then 1. Okay, so that is quite a long list there. And that is your prime factors. So how do I write that out? So again, on the right hand side here, that would be my prime factors. But like I said in class, do not leave them on the ladder. Take them off and write them out as a product. So 1296 is equal to the product of 2 times 2 times 2, that's 4 2's, so 2 times 2 times 2 times 2. And then there are also 4 3's, so times 3 times 3 times 3 times 3. And some of you might say, yes, why do we need to write it out individually? Why can't we just go straight to the exponential form? You could go straight to this by saying, okay, that I know is 2 to the power 4 times 3 to the power 4. You can go straight to that. It's quite all right. I'm just doing this, of course, to illustrate what is happening. So that is 1296, and the next one would be, of course, 3375. So I'll do that. So remember, this is all part of 1.4. Here you need 2 ladders, one each for the two numbers. So 3375. And the smallest prime that can go into that one, I think, will be 3. Yeah. Of course, there is such a thing called the rules for divisibility, and we may do a session on that a bit later. If you know your rules for divisibility, you would know immediately or a lot quicker which is the smallest prime number that can divide into these larger numbers, simply because you know your rules for divisibility. In other words, which numbers can divide into other numbers. So 3,375 divided by 3 gives us 1,125. And here again, I think it is 3. Yep. So that's 3, and that gives us 375. This is probably 3 again. 125. Again, I'm checking to see what is the smallest prime number that can go into the numbers on the left. The smallest prime number, not any small number, the smallest prime number. Here it would be, is it 3 again? No, it's not, because you're getting a decimal number. So 125, the next one would be 5. 25 divided by 5, and that of course gives us 25. So 5 goes into 125 25 times. Of course, we know the smallest prime number going into 25 is also 5. So 25 divided by 5 is 5, and then 5, and then 1. Right, so 3,375 is equal to 3 times 3 times 3. So that's 3 3's and 3 5's. Okay, and in exponential form, that would be 3 to the power 3 times 5 to the power 3. And that, of course, oh, that's the end. Nothing more after that. Right, so we've got here, we've got our two ladders, we've got our products or prime factors for the two numbers. For 196, it is these guys over here, and for 3375, it is those guys over there. Right, so what's left for us to do now is to find the LCM. So the LCM here works. LCM, it's a bit of a challenge for many of you because it works differently from the highest common factor, of course. For the LCM, remember LCM refers to the lowest common multiple, and we're talking about multiples of 1,296 and 3,375 multiples of those numbers, which is quite big numbers. If you start counting in 1,296, your numbers double, or they become large quite quickly, even more so for 3,375. So what I'm trying to say is the lowest common multiple is going to be quite a big number, and to choose them, or to choose that particular LCM from these guys, which is your prime factors here as well, you are not going to only choose the common factors. You're actually going to choose all of them. You're going to choose a representative, basically, of every factor that you see between the two sets. So the two sets I'm referring to, that's the one, and this is the other one. So out of those two sets, you need to choose. Okay, so you see, okay, I've got 2 there. So how many 2's do I have in either one? I only have 2 to the power 4 in the top one. So he must be part of my LCM, and that is 2 to the power 4, so I'm going to write 2 to the power 4. Right, next, I've got 3 as a factor in both numbers, and I want the one with the biggest exponent. So there's a 3 to the power 4 here, and there's a 3 to the power 3 over here. I want the one that's the biggest, so I'm going to choose 3 to the power 4. So it's all about choosing the largest of all the numbers. And then lastly, so you might say, okay, but I'm done because 5, you might say 5 is only appearing in the bottom number, but it's not about the common here, and that's where the confusion comes in, because the LCM does speak of lowest common multiple, but it works slightly different here. So you want to choose every number that is in there. So 5 to the power 3 will be included. So now I've got a representative of every factor that appears across both numbers. Okay, so I've got 2 to the power 4, I've got 3 to the power 4, which is the highest of the 3's, and I've got the 5 to the power 3, which is representing the basis of 5, or the factor of 5. So again, our LCM is not just a product, it is a number. So of course I need to multiply that out. So I've got 2 to the power 4, which is 16, times what is 3 to the power 4? That's 3 raised to the power 4, which is 81, and 5 to the power 3, which is 125. So multiplying all that together, I've got 16 multiplied by 81 multiplied by 125, and I've got 162,000, and that is my LCM.